everyone, welcome back to my channel. In this video lecture, we will cover a new chapter of physics, that is motion in a straight line. So first question that arises in our mind, that is, what is motion? If an object changes its position with respect to its surrounding with time, then it is called in motion. What is rest then? If an object does not change its position with respect to its surroundings with time, then it is called at rest. Point mass object. An object can be considered as point mass object if the distance traveled by it in the motion is very large and in comparison to its dimensions. Types of motion: one dimension motion, two dimension and 3D motions. Now what is distance? The length of the actual path traversed by an object is called the distance. It is a scalar quantity and it can never be zero or negative during the motion of an object. Its unit is meter. Then what is the displacement? The shortest distance between the initial and the final position. Please force this word: initial and the final position of any object during motion is called displacement. The displacement of an object in a given time can be positive, zero or negative. It is a vector quantity. Its unit is meter. Speed. The time rate of change of position of the object in any direction is called speed of the object. Speed is equal to distance travelled upon time taken and its unit is meter per second. It is a scalar quantity. Then uniform speed. If an object covers equal distance in equal interval of time, then its speed is called uniform speed. Then what is non-uniform or variable speed? If an object covers unequal distance in equal interval of time, then it is called non-uniform or variable speed. Average speed. The ratio of the total distance travelled by the object to the total time taken is called average speed of the object. Average speed is called total distance upon total time taken. If a particle travels distance s1, s2, s3 or with speed v1, v2 and v3, then average speed would be s1 plus s2 plus s3 plus sn upon s1 upon v1 plus s2 upon v2 and etc. Then instantaneous speed. When an object is traveling with variable speed, then its speed at the given instant of time is called its instantaneous speed. Instantaneous speed is equal to delta s upon delta t, which is equal to ds upon dt. Then velocity. The rate of change of displacement of an object in the particular direction is called its velocity. Velocity is equal to displacement upon time taken. Its unit is meter per second. Its dimensional formula is m0 to t minus 1 and it is a vector quantity as it has both the magnitude and the direction. The velocity of an object can be positive, zero and negative. Uniform velocity. If an object undergoes equal displacement in equal interval of time, then it is said to be moving with a uniform velocity. Non-uniform or variable velocity. If an object undergoes an equal displacement in equal interval of time, then it is said to be moving with a non-uniform or variable velocity. Now relative velocity. Relative velocity of one object with respect to another object is the time rate of change of relative position of one object with respect to another object. Then average velocity. The ratio of the total displacement of the total time taken is called average velocity. Average velocity is equal to total displacement upon total time taken. Now the acceleration. The time rate of change of velocity is called acceleration and it is equal to change in velocity upon time interval. Its unit is meter per second square. Its dimensional formula is m0 l1 t minus 2 and it is a vector quantity. Acceleration can be positive, zero or negative. Positive acceleration means velocity increasing with time and zero acceleration means velocity is uniform, while negative acceleration retardation means velocity is decreasing with time. Then displacement time gaps for a stationary body. Body moving with constant velocity, body moving with constant acceleration, then body moving with constant retardation and body moving with infinite velocity, but such motion of a body is never possible. Now velocity time graphs. Moving with constant velocity, moving with constant acceleration, body moving with constant retardation and its initial velocity is not zero. Then moving with a constant retardation, moving with increasing acceleration and moving with decreasing acceleration. Slope of this velocity time graph gives the average acceleration. Okay. Then acceleration time, when object is moving with constant acceleration, when object is moving with constant increasing acceleration, when object is moving with constant decreasing acceleration. Equations of uniformly accelerated motion. If a body starts with velocity u and after time t, its velocity changes to v. If the uniform acceleration is a and the distance travelled at time t in s, then the following relations are obtained, which are called equations of uniformly accelerated motion. First equation of motion is v equals to u plus at. Second is s equals to ut plus at square. Third is v square equals to u square plus 2ac. The distance travelled in nth second is equal to u plus a upon 2 bracket 2n minus 1 bracket close. And if a body moves with uniform acceleration and velocity changes from u to v in a time interval, then the velocity at the midpoint of its path under root u square plus v square upon 2. Then motion under gravity. If an object is falling freely, that is initial velocity 0 under gravity, then equation of motion is equal to, first will be v equals to u plus gt, second will be h equals to ut plus gt square, third would be v square equals to u square plus 2gh. Note, if an object is thrown upward, then g is replaced by negative g in above three equations. It thus follows that time taken to reach maximum height is equal to u upon g, that is equal to root 2h upon g. Then maximum height reached by the body, u square upon 2g. Then if a ball is dropped from a building of height h and it reaches after t seconds on earth, from the same building if two balls are thrown, one upward and another downside, with the same velocity v, and they reach the earth's surface after t and t1 and t2 seconds respectively, then t equals to, total time taken equals to under root of t1 and t2. They will be multiplied. Then when a body is dropped freely from the top of the tower and another body is projected horizontally from the same point, both will reach at the ground at the same time. So thank you for watching my video. Hope you liked it and understood it. This much for today's video. And don't forget to share, comment and subscribe my channel. And don't forget to like, share and comment my videos. Thank you.